Hi everyone. Let's begin by understanding what is quantum computing. Quantum computing holds the promise to solve some of our planet's biggest challenges in the areas of environment, agriculture, health, energy, climate, material science, and others we haven't encountered yet. For some of these problems, classical computing is increasingly challenged as the size of the system grows. Quantum computers are controllable quantum mechanical devices that exploit the properties of quantum physics to perform computations. For some computational tasks, quantum computing provides exponential speedups. These speedups are possible thanks to three phenomena from quantum mechanics: superposition, interference, and entanglement. Just as bits are the fundamental object of information in classic computing, qubits, that is, quantum bits, are the fundamental object of information in quantum computing. While a bit or binary digit can have a value either 0 or 1, a qubit can have a value that is either 0, 1, or a quantum superposition of 0 and 1. A fundamental difference between classical computers and quantum computers is that programs in quantum computers are intrinsically probabilistic, whereas classical computers are usually deterministic. In quantum algorithms, each possible result has an associated probability amplitude. After a measurement, one of these possible states is obtained with a certain probability. This fact contrasts with classical computing, where a bit can only be deterministically 0 or 1.